Alright guys, welcome to this page of the notes, and again we're just going to continue with graphing rational functions, and we're going to do this one. Now we've already looked at 3 of these. Some of them are pretty tricky, some of them are more straightforward. This one is, this one's tricky. This is another tricky one, and not because anything is really difficult to find. I'll show you why in a second. This one's actually, I don't even want to call it tricky, let's call it sneaky. This one's really sneaky. Here, I'll point out to you as we work through this one. So let's work through this one together and see what happens. Here we go. X-intercepts, no problem. Set the numerator equal to 0. X squared, it's a plus 4x plus 4 equal to 0. Let's hope and pray it factors easily. I really don't want to do the quadratic formula again. I need 2 numbers multiplied to a positive 4, sum to a positive 4. Whew, that's not that big a deal. It'll be a plus 2 and a plus 2. Set each of those equal to 0. X plus 2 is equal to 0. I get x equals negative 2. X plus 2 is equal to 0. I get x is equal to negative 2. The same answer shows up twice. No big deal. You just have multiplicity of minus 2. Your x-intercept, it looks like, it appears, remember this one's sneaky, it appears I have an x-intercept of minus 2. But I don't know. We'll see. Let's keep going. Vertical asymptote. Set the denominator equal to 0. X plus 2 is equal to 0, which means x equals minus 2. So I get minus 2 in the x-intercept. I get minus 2 as a vertical asymptote. Well, we know whenever it shows up in both, that actually is, well, we would think, actually be PD. But here's where this one's different. In all of the previous problems where we had point discontinuity, we were left with another either x-intercept, or we were left with another vertical asymptote. However, if negative 2 is neither an x-intercept nor a vertical asymptote, look at what I'm left with. I'm left with, it would appear, no x-intercepts and no vertical asymptotes. Wait, what? We have never seen a rational function that doesn't have a vertical asymptote. And this should be for you, or will be after we get done with this problem. This is going to be a red flag. Something's going on here. Something's up. We'll see what's up again. This one's sneaky. This is a sneaky one. All right, the degree of the top. The degree of the top is 2. Degree of the bottom is 1. Okay, all right, well, AX is greater than BX. That means I have rule number 1. That means, for now, right, I have no horizontal asymptote. I'm actually going to have a slanted asymptote, so let's go ahead and go through the algebra to find that. We'll come back to what all this stuff means here in just a second. But hang on a second, that red flag is going something's up here. This looks like a sneaky one. Let's figure it out. Okay, I take a look at it. I know to find a slanted asymptote, I have to do long or synthetic division. Please, synthetic work. Yes, synthetic works. My leading coefficient is a 1. So good, awesome. All right, so I take x plus 2, set it equal to 0. I'm going to do synthetic division with a minus 2. Make sure you check for placeholders. X squared, x to the first, x to the 0. Everybody's there. I don't need placeholders. 1, 4, 4. So 1, 4, 4. Bring down that first number. Multiply and add until you run out of numbers. Remember, you don't need the remainder. We don't care. You just want the quotient without the remainder. Negative 2 times 1 is a minus 2. Add them up. 4 plus a negative 2 is 2. Negative 2 times 2 is a minus 4. I wind up with a remainder of 0. And now, boom, that red flag that started going off down there at the bottom is now, I'm like, okay, I got this. What does it mean when you get a remainder of 0? Well, recall, a remainder of 0 tells you, from back in chapter 5, that my numerator is evenly divisible by my denominator. That means I can divide the top by the bottom and get no remainder left over. It's evenly divisible. So here's where that little red flag comes in. What this tells me is that if I were to factor the top, I'm going to get an x plus 2 that cancels out. So right now, I thought to myself down here, gee, that's really weird. No x-intercepts, no vertical asymptotes. I've never seen that before. Red flags kind of waving. I come up here, I do the synthetic division, I get a remainder of 0, and now it's clicking. Okay, here's what's going on. I take that function, f of x, which is equal to an x squared plus 4x plus 4 over x plus 2, and I factor this guy, right, which factors into x plus 2 times x plus 2 all over x plus 2, and look at that, right? Factor in the top, factor in the bottom, those guys cancel each other out, and look what you're left with. Guys, this is not a reciprocal function. This is a linear function. I have f of x is equal to x plus 2. If you prefer, f of x is equal to x plus 2, or you could write it as y equals x plus 2. It turns out, while it looks like a radical function, good grief, while it looks like a rational function, it isn't. I have a GCF, top and bottom, that cancel each other out, and this guy, this function, is a linear function. Y equals mx plus b. It's a linear function in disguise. It's sneaky. It's a sneaky one, right? And I found that right here, right? By doing the synthetic division, decrease the degree by 1, this guy turns into y equals x plus 2, right? By whether I do the synthetic or I recognize it down here, right? It's not actually a rational function. It's a linear function. It's a straight line. And I got that red flag in 2 places that kind of let me know, well, something's going on here. This one's sneaky. So go ahead and graph the line. I have a y-intercept of 2. I have a slope of 1. 1, 2. Oh, no. Let me do it in a different color. There we go. There's 2. Slope of 1. So that guy's going to run right up through there and run right down through there. Please notice that my graph goes through x equals -2. Right? X equals -2. That's why it showed up in all those spots down there. It showed up as an x-intercept, showed up as a vertical asymptote, showed up as point discontinuity. Right, that was kind of my red flag. No, it's because that's where I crossed the x-axis. But it is not a rational function. Turned out to be a linear function. It's just a straight line. Actually, I don't know why I made it dotted. This is my function. Make that a solid line. That is my function. It was being sneaky. It was in disguise. All right, so guys, watch out for that. Sometimes the red flag will start a waving. Look out for it. Especially, you'll know there's something going on. If you do that synthetic or long division, you wind up with a remainder of 0. That'll kind of be your, like, okay, something's up here. It'll probably wind up being a linear function. So watch out for those. Keep an eye out for them on the homework. Of course, on a quiz or a test. Actually, really not that difficult once you work your way through it. You probably will even get pretty good at spotting them pretty quickly. So head on over to the next page of the notes. We'll try another one of these. We're just going to keep on graphing. I'll meet you guys there.